Mayday! Mayday! Oh, wait, Mayday was Saturday. Never mind. Wow, we're in May now. That's the last month of school this year. Wow. For some of you, it feels like March was the last day of school because we haven't seen each other in that long. We haven't been able to hang out with our buds, have that wonderful cafeteria food. Maybe you can ask Mom to just whip something up just like the cafeteria does for lunch today or something. But anyway, we are going to spend another lesson on the quadratic formula, part 2, applying the quadratic formula, part 2. And then later on in the week, we're going to look at some rational, irrational numbers, kind of just picking and choosing what we want to cover the rest of this time because it's May. We're almost out of time. So we want to make sure we pick up a few of the key things that would be good to know headed into geometry next year. So we'll cover a few things here before the year's out. Applying the quadratic formula. Let's get to it. Let's not spend a lot of time dilly-dallying around. What you say, huh? Well, all right. Applying the quadratic formula, part 2. So, all right. Let's get into this. This says, evaluate each expression for a equals 9, b equals -5, and c equals -2. Okay. So we might recognize that A, B, and C. We have to use those. These are pieces. This is bits and pieces. These are pieces of the quadratic formula, right? This isn't the entire quadratic formula. This is pieces of it. And right here, I'm telling you what A, B, and C is. You should be able to know by looking at a standard equation set equal to 0. But I'll give it to you on this one because we just need to know still, can we do the little pieces. So it says B is -5. So negative B, if B is -5, negative 5 would be -5 would be +5. +5 because a negative B, negative 5. B squared. So -5 times -5 again makes that a positive. Negative times a negative. We can't square anything and it ends up negative. 25. B squared minus 4 times A times C. Okay, well, we know what B squared is. We just calculated that. So 25 minus 4 times, what's A? A is 9. What's C? C is -2. So that would be the same as 25. Let's see. Let's do 4 times -2. -8 times 9 would be 72. So if we're subtracting a -72, we're going to add 72. So 25 plus 72, 97. So B squared minus 4AC is 97 for our A, B, and C that we have. And negative B plus or minus the square root of A. Okay, negative B. Again, B was -5, so negative B would be a +5 plus or minus the square root of 9. And what is the square root of 9? 3. So it'd be 5 plus 3 or 5 minus 3. So our answers are 8 or 2. So we have 2 answers, 8 or 2. Okay, just a little refresher for using the quadratic formula. Because we're going to look at some work that somebody else did. It's always fun to do. Using the formula with care. Please care. No, I know you care. Here are 4 equations. All right. Equation 1, 2, 3, and 4. Followed by, I already have them solved. I've handed them out. I have 4 people solved them. I have their work. It's all typed up here. We're just going to look at it and see how they did. Because all of them messed something up. I've already looked at all 4 of them. They messed it up somewhere. So they weren't quite able to get the right solution. Because when you're doing all this work, if you make one little mistake, you're going to end up in the wrong answer at the bottom, right? So it's important to make sure you're doing each step properly. That's why we looked at little pieces. Can we do each little piece properly? Because if you do one piece wrong, you're wrong the rest of the way. So here's the equation. 2x squared plus 3 equals 8x. So that means A equals 2, B equals -8. Why does it say -8? This says +8. But it's not equal to 0. Remember, we can only use the quadratic formula when it's equal to 0. So you got to subtract 8x from both sides and rewrite it as 2x squared minus 8x plus 3 If it's not equal to 0, you need to do that first, or you have the wrong sign on your A, B, or C, whichever one's on the other side. In this case, B was on the other side, becomes a negative. So it is -8, and C is 3. So we can see it, 3. Okay, so here is the first equation and how they solved it. All right, so x equals, these are all x equals, -b plus or minus the square root of b squared minus 4ac over 2a. That is the quadratic formula, right? So that is just writing the formula so they know their starting point. First thing we do, you just substitute. -8 plus or minus the square root of -8 squared minus 4 times 2 times 3 over 2 times 2. We good so far? All the a's became 2's. All the b's became -8's. All the c's became 3, which there's only one c. So that was easy. So it looks like they properly substituted. We're good. Okay, so then said -8 is 8 plus or minus, and all this under here they said, well, -8 squared is 64. 4 times 2 is 8 times 3 is 24, so it's 64 minus 24, and it's all divided by 2 times 2 is 4. Are we good? Let's see. Let's keep moving. So 64 minus 24 is 40. So this was a simple step there. 8 plus or minus the square root of 40 divided by 4. So they said, okay, let's get rid of the divided by 4. So 8 divided by 4 is 2. Square root of 40 divided by 4 is square root of 10, because 40 divided by 4 is 10. So the answer is 2 plus the square root of 10 and 2 minus the square root of 10. Didn't take that any farther because the square root of 10 is not a whole number. It is a repeating, not a repeating, but it's a decimal that keeps going. We don't want to round it because our answer will be wrong. If it's rounded, this is the correct answer. So 2 plus square root of 10, 2 minus square root of 10. So I said all of these had a mistake. Where did they go wrong? That's right. -8 squared is 64. 4 times 2 is 8. 8 times 3 is 24. So it is minus 24. 2 times 2 is 4. That's good. All they did from this step to this step was subtract 24 from 64. And that's right. So that means we have a problem right at the end. What did we do? Kind of goes right here. We cannot divide the 40 by 4. It doesn't work that way. Let's see an example of why that would be true. Let's say we're going to have the square root of 100 divided by 2. Okay, square root of 100 divided by 2. Now we know what the square root of 100 is, right? It's 10. 10 times 10. So this is saying it's 10 divided by 2, so the answer should be 5, right? Because 10 divided by 2 is 5. But if we divided that first before we took the square root, 100 divided by 2 would be the square root of 50. The square root of 50 is not 5. It's a decimal. It's some, here, we can even pull it up here. The square root of 50 is, there you go, 7.0710678812, and it continues. That's where the calculator stops showing us. It's not the same answer. This is not a legal operation. You have to do this first because this is not under that with it. If this was all the way down there, that's different. Then it's the square root of 50. But the 2 was not underneath the radical. It was not the square root of. So that's where the problem is. This is not correct. This is not correct. So there's wrong answer right there because they did something illegal operation. Cannot do that. All right, let's try another one. Let's look at equation number 2. Here was the second equation. X squared plus 3x equals 10. So I said, okay, A is 1. See, it's just x squared, so that's 1x squared. B is 3, C is 10. So negative b plus minus b squared minus 4ac over 2a. Again, we just write the quadratic formula down. Negative b, so they said negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 10 all divided by 2 times 1. Okay, that's just straight substitution. So I said negative 3 plus or minus 3 squared is 9. They said 4 times 1 times 10 is 40. So the next step, they said 9 minus 40 is negative 31, which 9 minus 40 would be negative 31 divided by 2. So they said there's no solutions because this number does not exist, which is true. You cannot take the square root of a negative number, right? Because there's not two numbers you can multiply back to get to the negative 31 that are the same number, because square root would be the same number multiplied by itself to get back to the original number. So, yes, there are no solutions if that was done correctly. This was not done correctly. There was a problem. Did you catch it when I was going through it? The problem was before this. We shouldn't have ever ended up with the negative 31 under there, because there is a solution to this one. This does have two solutions. The problem, was it up here? No, it was before that. Before that, the problem is right up in here. This equation is not set equal to 0. Got to move that 10 over first. This should be x squared plus 3x minus 10 equals 0. We have to subtract 10 from both sides and move that over. So C is not 10. It is negative 10. Negative 10. And that would change everything, because this would be suddenly 4 times 1 times negative 2 be negative 40. And when we subtract a negative 40, now we're adding 40. So 9 plus 40, no problem. We can take the square root of 49. We cannot take the square root of negative 31. So that's where the issue is. All right. Problem was right there at the beginning. Right there at the beginning. Let's try another one. Okay. 9x squared minus 2x minus 1 equals 0. Okay. It's set equal to 0, so we're not going to be fooled there. So they said A is 9, B is negative 2, C is negative 1. Here's our quadratic formula. Substituting 2 plus or minus. They went from negative B, say that would be 2 plus or minus the square root of negative 2 squared minus 4 times 9 times negative 1 all over 2. So then they said 2 plus or minus, they said negative 2 squared is a positive 4. Okay, that's right. Negative 2 times negative 2 plus 36. Well, they had minus a 4 times 9 is 36 times negative 1 is negative 36. So minus negative 36. So they said plus 36 divided by 2. So 4 plus 36 is 40. So they said the answer is 2 plus or minus the square root of 40 divided by 2. Which the square root of 40 is 6 point something. So we leave it like it is because we put it in a decimal. We're going to round it. That's not the same answer. Not when your decimal doesn't end. If it was 2.5, not technically a difference there. 2.5 ends. This decimal doesn't end. It keeps, you're going to have to round it. So 2 plus or minus square root of 40 over 2. Is this correct? No, because I already told you there was a problem. Where was the problem? Did you catch it coming down there? Let's see. Did we substitute correctly? A was 9. A is right there, and right there, and right there. And where did our A go? We did not multiply the denominator by 9. It's supposed to be 2A on the bottom. We just dropped off the A and just said divide by 2. It should have been divided by 2 times 9. It should have been divided by 18. That was a problem. They dropped it right there. So there's our error right there. Right there's our problem. All right. Let's look one more. X squared minus 10x plus 23 equals 0. Again, we are set equal to 0, so we're good there. So A is 1, B is negative 10, C is 23. Are you checking to see if that's right as I go through this? Here's our quadratic formula. So negative B, negative 10, plus or minus negative 10 squared, minus 4 times 1 times 23, divided by 2, 2A, 2. So negative 10 plus or minus square root of negative 100, because they're squaring that, minus 92, because 4 times 1 times 23, That is 92. They did the math right there. Well, negative 100 minus 92 is negative 192. No solutions. Again, because we cannot take the square root of a negative. But there's a mistake. What happened? Actually, looks like there was two mistakes, technically. Did you catch it? B, what is B? B is negative 10. So what is negative B? Negative B would not be negative 10, because B was negative 10. It should be positive 10. So this right here should have been a positive all the way down. That's one mistake. But that wouldn't have made a difference, because 10 plus or minus the square root of negative 192 still doesn't have a solution. And this has solutions. So that wasn't the only problem. The other problem is right here. Negative 10 squared. What is negative 10 times negative 10? It is not negative 100. It is positive 100. Remember, a negative times a negative. This should have been a positive. If that was a positive 100 and we subtracted 92, no problem. We've got a positive 8. We can take the square root of 8. Again, it's not a whole number, so we're going to leave it as the square root of 8. It'd be 10 plus or minus the square root of 8 divided by 2. But those are solutions, as opposed to this that were no solutions. So pay attention to those little things when you're using the quadratic formula. Make sure you're not making those little mistakes that you get to the end, you're like, I don't know how to do this. There's a little mistake in here. Pay attention to the details. All right, here's our last problem we're going to look at today. So we've got a lot of tools to solve quadratic equations now, right? We can factor them, we can graph them. If we factor them, we use the zero product property. Say I got two factors, I'm going to set this one equal to 0, and I'm going to set this one equal to 0 if the equation equals 0. And that'll tell me the solutions. Graphing, we have the big guns now. We've got the bazooka of the quadratic formula that will certainly solve that equation for us. So let's see what option we want to use here. All right, the equation, R of P, which is revenue, equals 80P minus P squared. This models the revenue that a band expects to collect as a function of the price of one concert ticket. All right, so whatever the P, whatever price they decide to make the ticket, this formula will give them the amount of money they're going to end up, the revenue. So ticket prices and revenues are in dollars. A band member says that a ticket price of either $15.50 or $74.50. So, it's a quadratic formula, so it means it's going to have two places that would be x equals 0, right? That'd be two solutions. So he says $15.50 or $74.50. Either one would get them $1,000 revenue. So we can either charge $15.50 a ticket and we'll sell a lot more tickets and get $1,000, or we can charge $74.50. We won't sell nearly as many tickets, but we'll get $1,000. That's the two numbers. Do you agree? Show your reasoning. So what method would you like to use there? Our equation would be 80P minus P squared equals 1,000. Right? Because that's how much revenue he wants, 1,000. If we want to set that equal to 0 and use the quadratic formula, our C is going to be negative 1,000. So we're going to have some pretty big math. Our B, this is the linear, this is B. Remember that whatever goes with the squared term, the quadratic term, that's the A. B is going to be 80. So we're going to have to square 80. And we get some pretty big math using the quadratic formula. Calculators don't care. It would work just fine. We could put this equal to 0 and try to factor it. What numbers would we need to get to multiplied to be 1,000? And yet when we add up the middle term, it ends up at 80. Our multiplies would be negative 1,000 when we move it over. And then set those equal to 0. This sure looks like an ideal case to just graph it and see, right? Now, I'm not going to graph this by hand. That's some big numbers there too. But I have it on the computer. Let me switch over here. Let's look and see what it looks like. I've already typed it in. You see up here, I put 1,000, which is our revenue, equals, and I had to make it x's for the graph because we have x's and y's, not p's on here. So 80x minus x squared. Same equation, just on a graph. And so we can just look at this and see what the values are. And looking at the graph, I'm not seeing anything. You see anything on the graph? Oh, there's the problem. I got it right there. Small graph, big numbers. Let's zoom out a little bit. Let's do that. Let's say if we go in the graph. Oh, here's the graph. It's there. We just got to move over here where the numbers are. There it is. Okay, so here is, this is a quadratic. The vertex is probably way up there since we have 1,000 in this and an 80. The vertex is way up there. All I care is about the zeros, right? That's the two solutions. Where it equals 0, that's the two solutions. So it equals 0 right here at 1550. What did he say? He said 1550. Okay, 1550 would generate 1,000. And then he said 7450. Does that work? That is not 7450. That is like 6450. $10 off. If he charged 7450, probably wouldn't hit their $1,000, so he wouldn't sell as many tickets as he thought he would with the equation, if the equation's correct. So remember, we got lots of ways to solve these. Graphing works. This may or may not be rounded to 3 decimals, but since we're talking about dollar amounts, that's fine because we just need it to 2 decimals for cents, right? We don't need to know 5 and 6 decimals for dollar amounts. But on some things, we wouldn't want to graph it if we need a more precise answer. Then we can just use that quadratic formula. We got a calculator. We don't care. It'd be just fine. But yeah, figure out what tool works best. Figure out what tool works best when you want to solve these problems. So today you'll have some problems that will go through some of those quadratic stuff again. I have a problem I want you to solve by the quadratic formula, a few things. And the last problem up there's not a whole lot of problems. I want you to see if you can factor. Remember factoring? I'm going to take x squared plus 5x plus 4, and I'm going to break it to x plus 1 and x plus 4. Set those equal to 0. Solutions are -1, -4. Factor it. See if you can do that. Show me your work. Factor it. Set equal to 0. Tell me what that equals. See if we can do that. Otherwise, welcome to May. It's getting hot now. April was like warm, cold, warm, cold, warm, cold. May's going to come in, and now it's going to start smoking us up here, especially after all this rain. I'm feeling it today. All right, well, the cat is begging to come in the room, so I guess I better get out. My time is up. So do work you can be proud of.